Right. So in the last video, we obtained a relationship between linear velocity and the angular uh, velocity. So this was the equation we obtained, right? V equals R omega. So if you know V and R, you can calculate omega. So if you know omega and radius, you can calculate the linear velocity. Or if you know both of these, linear velocity and the angular velocity, then you can calculate the radius of the circular path in which the motion takes place. Right. So in this part, we're gonna obtain a relationship for the acceleration. Now, since it is moving in a circular path, then we're gonna have to study the acceleration in two directions. Now, here's the thing. Again, we start from the same diagram. When the particle moves from A to B, it changes by an angle of delta theta. That means it takes time to go from here to here. Therefore, that means there's a rate of change of this angle, right? Now, at position A, the velocity is v, and v is the speed of this velocity, and this is the direction. When it is at B position, the speed is v plus delta v. We analyze the general situation, so that's why I changed this velocity here. If it is uniform velocity, then this would be easy derivation. And this direction is the direction of the velocity. This is the speed, this is the direction. Now we're gonna calculate the acceleration in two directions. That means direction towards the center, direction towards the center, right? And the direction that is tangential to this circular path. So I have made a small sketch here. You can see that since the direction changes by an amount delta theta, right? That means there will be an acceleration. Even though the speed does not change, due to the change in the direction, there will be an acceleration, because acceleration is defined as rate of change of the velocity. Velocity is a vector, so a vector can change both by direction and or magnitude, right? So even the direction changes, there will be acceleration accompanied with it. Now here's the thing: we're gonna divide the resultant acceleration into two components. This is the tangential component, and this is the radial component, right? This is the change in the direction of the speeds, right? So we call this linear acceleration by a sub r and centripetal acceleration by a sub c. So if you take a sub c, sorry about that. Now, if you define a sub c, what is a sub c? A sub c is an acceleration. It is an acceleration. Therefore, you have to start from the definitions of acceleration. A sub c, it is a limit as delta t tends to 0. Limit as delta t tends to 0. The rate of change of the velocity. So rate of change of the velocity can be obtained by final velocity is v plus delta v. In this direction, it is the component is v plus delta v sine delta t. Sine delta t minus 0, because initially you did not have any velocities towards the center, divided by delta t. Right. So I have to evaluate this limit delta t tends to 0. So since this is a product, so I'm gonna separate it out and limit as delta t tends to 0 sine delta t divided by delta t. So you know that as delta t tends to 0, v delta v also tends to 0. Therefore, this part will be v. This part will be v. And what about this part? To evaluate this in limit, I'm going to make a small change here, sine delta theta. I'm going to divide this by delta theta and multiply it by delta theta. Then I divide this by delta t. Now I can apply the limit to this product separately. So if I apply the limit to this one, you know it is equal to 1. It's a basic trigonometric limit. If I apply the limit to this one here, apply limit to this one, what is this? This is v dv by dt. This is dv by dt. Right? That is the definition. So what is dv by dt? dv by dt, sorry, d theta by dt. Sorry about that, d theta by dt. So we can write it as v theta dot v theta dot, or we can write it as v theta dot is omega. Theta dot is omega. Right. So what is omega? From the previous equation, you found that omega is v divided by r. So we get a relationship v squared over r. Okay. Or we can replace v with the equation that is r omega. And you have omega when you get r omega squared. Now we have two equations. So two formulas actually. The first formula is AC v squared over r. Or we can use AC r omega squared. We can use both of them. So depending on the problem, you can choose whatever you like. Next, we'll look at the acceleration towards the tangential direction. So AR would be, AR can be defined as limit as delta t tends to 0. In this direction, v plus delta v cos delta theta. So v plus delta v cos delta theta minus, so starting velocity would be v in the same direction, v. Then you have to divide it by delta t because we are looking at a rate of change of velocity. Now let me rearrange this. Limit as delta t tends to 0. So I can factor out v from this, then v cos delta theta minus 1. Then plus delta v cos delta t divided by delta t. So I'm going to apply delta t division to both these expressions. Right. So what is this? Limit as delta t tends to 0, v cos delta t minus 1. Cos delta t minus 1 is minus twice sine squared delta theta by 2. Okay. Divide by delta theta. Divide by delta theta. Plus limit as delta t tends to 0. This is delta v over delta t cos delta t. Now, if you take the limit, I'm not going to go through this. What you have to do is you're going to have to divide this expression by delta theta over delta theta over 2 squared. Delta theta over 2 squared, because then we can get rid of this trigonometric limit. And finally, when you divide it, you're going to have to multiply it by the same thing. Then this limit will become 0. So I'll let you guys do the workout. So what about this one? This part is, this part here, this part is dv by dt, dv by dt. So cos delta t goes to 1. So radial, in the tangential direction, the acceleration is dv by dt. So we can analyze this further, dv over dt. What is v? We obtain that v is r theta dot, r theta dot. So r is a constant, so you can take it out. Then here you get the derivative of theta dot. Derivative of theta dot is r theta double dot. R theta double dot. Right. So yeah, acceleration towards the standard direction is r theta double dot. This is the other equation. Now, if v does not change, uniform motion means implies dv over dt is equal to 0. dv over dt is equal to 0. Derivative of the speed, right? Derivative of speed is equal to 0. Therefore, this implies AR is equal to 0 for uniform motion. Okay, right. So let's look at more examples during the discussion. If you have any questions, you can refer them to me. Thank you for listening.